All right, so let's take a look at this equation right here, y equals 2x minus 5. Now what I want us to do is I want us to graph this using a t-table. So it's pretty simple. Just make a table that looks like a t. It's just the same thing that you would have seen on your graphing calculator. You pick whatever x values that you want. Now how many points does it take to uniquely determine a line? Anybody know?
3.
Nope.
2.
It only takes 2. If you have 1 point here and 1 point here, how many different lines go through those 2 points? Just that one line, right? Now why do you think I'd want you guys to pick 3 points? So you know for sure. So if I do say 0, 1, and 2, these are really. So these are usually my values of choice to plug in here. So if I plug in 0, that means you're replacing the x with 0. What do you get? 2 times 0 minus 5, so 0 minus 5 is negative 5. If I plug in 1, 2 times 1 minus 5 is what? Negative 3.
Oh, 2.
If I plug in 2, so 2 times 2 minus 5 is how much? 4 minus 5 is negative 1. Yet notice something special here, that every time my x goes up by 1, what's my y value doing? No, it's increasing by 2 as well, right? Okay, so let's plot these points and see what we have. I have 0, negative 5. I have 1, negative 3, and I have 2, negative 1. Do you think that I could take these points and extrapolate them? That means get more points in the same kind of pattern. Okay, how can I do that? What's the pattern as I go from one point to the next to the next?
Up 2 over 1.
I'm going up 2 over 1.
That way.
Up 2 over 1. I can keep doing that, right? Up 2 over 1. So keep doing that. And as you do that, the more points you get, the more accurate your line is going to be. Now I ran out of room as I was going up and to the right.
Sorry. How'd you get the negative 3 again? On the t-table?
This?
Yeah.
2 times 1 is 2, minus 5 is negative 3. Now here's something. If you get these 3 values here, these 3 points, and they don't form a straight line, then guess what? They don't form a straight line, then you've probably done something wrong. Okay? Because right now we are graphing lines. Later on, when you take O310, you're going to be graphing things that are not lines. Now, extrapolate and go the other way. So if I go backwards, go down 2 to the left 1, down 2 to the left 1. So what do you guys think? This makes a line, right? So let's connect the dots. Let's make sure we do this the right way. Make sure that your lines are straight. If they curve, you will lose points. If they do not go all the way to the edge or have arrows, you will lose points. You will be accurate, just like I'm accurate here. Okay? So what do you guys think about that? Looks all right? I mean, you could go further with your t-table and you could see that points do match up. If I picked 7, that means I'd have to do 2 times 7 minus 5. What is that?
9.
14 minus 5 is 9. Does that point match up with what I have here?
Mm-hmm.
Here's 7 and here's 9, so yes, that point matches up. And this is what the graph looks like when done in WinPlot. Side by side, these guys are exactly the same, right? Could you check this with your graphing calculator?
Yep.
How?
Plug it in.
Yeah, plug it in. So come back to your graphing calculator. And under y equals, we're going to change this to 2x minus 5. You type it in just the way you see it as long as it's solved for y. 2x minus 5, and then what do we do?
Graph.
Press graph. By the way, if you hit the enter button, it will pause the graph. Maybe there's something you need to see, or maybe you're graphing more than one line at once. You pause it, see what's going on here. Yeah, that so far looks like it's matching up. If you ever find that it's taking way too long to do something, or maybe got stuck in a process in the with the calculator, you press the on button, it will break it. It will do a complete break in the process. Like if I do this right now, it's not going to finish graphing no matter what I do. If I hit enter, it's not going to do anything because I stopped it completely from graphing. So I have to go back and press graph. It's going to graph the whole thing. But you can use the enter button as a pause feature to start and stop it as you go along there. So everything seems to match up, right? Now I want to show you something about your table. If you go second graph to bring up your table, the same kind of points that we expected to have, right? You've got the 0, 5, 1, negative 3. If you go all the way down here to 7, you see you've got the order pair 7, 9. You guys agree with that? But you can actually populate this t-table with your own values, not just what the calculator gives you. Above window, you see something that says table setup, so second window. And the table setup basically says, where does your table start? And this triangle in front of the table is the Greek letter delta, which in a math sense means change. So what's the change in your table? 1 unit. And you saw that every time you went down for x, it was increasing by 1. Come down here to the independent variable and go to ask and hit enter. Now, the independent variable is the guy that you have control over. When I was making up this t-chart, which one did I have control over? X. But as soon as I picked x, the y value depended on my x value, right? So that makes your y dependent and your x independent. It took me forever to finally make sense of that. Okay. So if I go to my table now, there's nothing here. So you can type in any value that you want to. If you want to know what it is with 0, or 1, or 2, or 7, you get the same table that we have here. What happens if I plug in 100? I get 195. It does the work for you to create your t-table. I could type in 3.5. You get 2. Other questions about that guy?